when Neil Armstrong and Buzz Aldrin stepped onto the surface of the moon. Their portable life support system backpacks allowed them to carry out moonwalk activities for 2 hours. However, if an astronaut tried to conduct a similar walk on the surface of Venus, it would last for 5 seconds, at best. Then the immense atmospheric pressure and high temperature would turn fatal. Welcome to Venus. They say that this is Earth's twin, but despite its serene appearance, it is nothing like our home world. In this episode, we will take a close look at our sister planet. Venus is a truly special place in our solar system, as it harbors and presents many secrets and mysteries. It is one of the small inner rocky planets, the second from the Sun and Earth's closest planetary neighbor. It was one of the 5 planets identified in ancient times, along with Mercury, Mars, Jupiter, and Saturn. Its movements were observed for centuries prior to the invention of astronomical instruments, with the earliest recorded observation made by Babylonian astronomers nearly 4,000 years ago. The first person to actually look at Venus through a telescope was astronomer Galileo Galilei in 1610. Its atmosphere was discovered by Mikhail Lomonosov in 1761. And his work was expanded in the 1920s with the development of ultraviolet sensing technologies. At the dawn of the space age, Venus was the first planet visited by a probe, when Mariner 2 flew past it in 1962. In other videos, we will highlight many of the missions since then that have explored and studied this magnificent world. So, why have humans always been so fascinated by Venus? One reason may be that it is the 3rd brightest object in the sky after the Sun and Moon. This is due in part because of its relative proximity to us, and in part because its thick clouds reflect approximately 70% of the sunlight back into space. Because of its brilliance, it is often called the morning star or the evening star. Directly comparing Earth and Venus as planetary bodies reveals one critical similarity and one stark difference. Since both planets are roughly the same size and mass, they experience roughly the same gravitational pull, with Venus's gravity equal to approximately 98% of Earth's. This is the only planet in the solar system that comes this close to matching ours. However, despite similar gravity, Venus's rotation around its axis is incredibly distinct. First, it spins backward from the rotational movement of its planetary neighbors so that the Sun rises in the west and sets in the east. Moreover, this retrograde rotation is so slow that it completes one revolution around the Sun faster than one rotation around its axis, which makes its day longer than its year. Specifically, its day is 243 Earth days, and its year is 225 Earth days. Although it is twice as far away from the Sun as Mercury, Venus is actually the hotter planet. In fact, it is the hottest celestial body in our solar system with an average surface temperature of 465 degrees Celsius or 870 degrees Fahrenheit. This is due to the fact that it has a thick atmosphere full of gases that trap heat. Also, the temperature on Venus remains relatively constant across the entire planet day and night, and from the equator to the poles due to the thick atmosphere's ability to distribute heat evenly. This atmosphere is the densest in our solar system, and it is composed of 96.5% carbon dioxide, 3.5% nitrogen, and traces of other gases, such as sulfur dioxide. It is precisely this dense atmosphere that creates a surface pressure about 100 times greater than Earth's, equivalent to the pressure found about 1,000 meters underwater on Earth. To make this world even harsher, the sulfur dioxide combines with water in the atmosphere to form sulfuric acid clouds, creating a highly corrosive environment. Speaking of water, scientists believe that Venus lost and continues to lose water through a process called dissociative recombination, leaving its atmosphere extremely dry. By comparison, the concentration of water vapor in the atmosphere of Venus is 0.002% compared to Earth's 0.4%. In fact, the planet's atmosphere is so dry that Earth-based and spacecraft-based measurements of the water vapor abundance are extremely difficult. Earth's geological processes are almost all a result of plate tectonics, as these plates float on our planet's mantle. However, Venus has no plate tectonics, even though some theories hold that it had plate tectonics in the past, but something unknown shut it down. Instead, Venus's surface is shaped by volcanic activity through a process driven by mantle convection. It is apparent that the surface of Venus is scarred with many tectonic and volcanic features, dominated by large plains of basaltic lava flows, numerous shield volcanoes, and complex geological structures. Because there is virtually no water on Venus and the surface wind speeds are low, almost nothing erases the features produced by the volcanic eruptions. Since sulfuric acid occurs naturally in volcanic gases, variations of trace gas species involving sulfur dioxide and other sulfur-bearing species in the upper atmosphere is proposed as possible evidence of volcanic activity. In fact, the average sulfur content corroborates ongoing volcanism on Venus. Scientists estimate that about 75% of the surface of Venus consists of lowland lava plains. Gamma-ray spectrometry measurements have determined that Venus's volcanic landscapes are made up of igneous rocks, predominantly basaltic in composition. In short, Venus may also be considered a true volcano planet. Venus has been an object of fascination throughout human history, and especially since the dawn of the space age. In the coming years, continued exploration and study of our sister planet promise to reveal more about its history, its dynamic atmosphere, and the processes that have shaped it into its current appearance. Moreover, it offers unique opportunities to answer fundamental questions about our own planet's potential future.